This is video 1 in a series of videos for optimization. I'm going to do one per problem because they're kind of long, and that way it can break it up a little bit better. So we're going to start off with this problem with Emmanuel the duck. And if you will, go ahead and make sure you have your calculators out. We're actually going to be using those pretty heavily in this lesson, which I'll be showing you some things on that as well. So optimization, what that means is we're going to be looking at various problems and optimizing something. So when we talk about optimization, we either are going to be minimizing or maximizing something. It's different than related rates. At first, these problems look like related rates problems, but they are not. With related rates, we were doing implicit differentiation and taking the derivative with respect to time. But these are actually easier problems than related rates. So let's just look into this problem and see how it differs. So we have Emmanuel the duck, which is just a little character that I like to use to help us introduce optimization. And he's broke, he has no money, and he decides that he needs to get a job. However, the only job available is at a circus. Emmanuel is reluctant to become the duck cannonball because he doesn't think it's safe. However, the owner will allow Emmanuel to build a water tank to land in, as well as 500 cubic feet of space to build it in. It will take Emmanuel 15 minutes to put up each square foot of material required for the cylindrical tank. So the question is, what size tank will take the least amount of time to build? We want to give the radius and height to give that measurement, and how long will it take to build the tank? So when we see this word least amount of time, that means we want to minimize time building. And when we talk about the time built, we are talking about building this three-dimensional figure, this cylinder. So we're talking about the time. It says he takes 15 minutes to put up each square foot. So we're looking at minimizing time, therefore we want to minimize square footage, which means we want to minimize the surface area of the cylindrical tank. Alright, so that's what we want to do. Our goal is to, first of all, minimize surface area, because if we minimize surface area, we're minimizing time. So obviously we would need a formula, just like with related rates, for surface area. So the surface area of a cylinder is the area of the base, and for a cylinder, we're looking at this actually open cylinder. If you look at this water tank, the top is going to have to be open, and then the bottom is closed. So for an open cylinder, the base is pi r squared, that's the area of the base, plus the lateral surface area is going to be the circumference 2 pi r times the height. So that represents the surface area of this open top tank. Now, we want to minimize surface area. So think about what we've learned about taking the minimum or finding the minimum or maximum of an object. So we want to take the derivative. However, when I take the derivative, we again have an issue because we have those radius and height. So we need to find a way to get this in terms of one variable only. Either r or h, it doesn't matter. And so the way we're going to find another relationship, just like related rates there, and that is with the 500 cubic feet. So that's the volume. So the volume of this cylindrical tank, we know we want to be 500 cubic feet. And we are going to use the full space here. Don't try to make it too complicated and try to minimize volume or whatever. So we are going to use a 500 cubic feet space. So what's the formula for volume of the cylinder? So the volume of 500 feet cubed is going to be pi r squared h. So we can create this relationship between r and h. Doesn't matter which one we solve for, so I solve for the easier one. So h is probably easier to solve for because it's not squared in this formula here, and there's only 1 in the surface area formula. So that's going to be easier. So h is equal to 500 divided by pi r squared, which will go and substitute into our surface area formula. Okay, to save time, I went ahead, wrote out my surface area formula, and then simplified, so you should have this formula. Again, we have not taken the derivative yet, so go ahead and take the derivative. Before I take the derivative though, I'm going to write my surface area prime with respect to r. So again, you're not taking the derivative with respect to time. This is not implicit, so this is where it becomes easier because you're just taking the derivative with respect to the radius. Because we want to know is, as the radius changes, what's the largest or the smallest, in this case the smallest, surface area. So we want to minimize surface area, we want to know what radius gives us the smallest surface area. We're not talking about a rate of change with respect to time. So take the derivative now with respect to r and simplify. Hopefully this is what you get. So now that we have the derivative for surface area with respect to r, we want to minimize this. So to find a minimum, we want to find where the derivative is undefined and also equal to 0. Now this derivative is undefined if you look at the 1,000 divided by r squared. It's undefined at 0, but we wouldn't have any surface area anyway at 0, so that's not going to pose a problem. So we're going to set our derivative of surface area equal to 0 itself, and then solve for r. So again, I'm going to pause it and do this quickly. So what I would do first is add 1,000 r divided by r squared to the other side, and then solve for r. Go ahead and do that now. Okay, so I went ahead and solved completely for r. Now when you get down to the 500 divided by pi and then taking the cubed root, this is where I would use your calculator. For most optimization problems, you will be allowed to use your calculator. If you're not allowed to use your calculator, it'll be pretty easy to solve for. So here's our r, and now what we want to do, and I'm going to kind of go through a tutorial on the calculator as well, is we want to make sure that this is in fact a minimum value. So what this tells us is that when the radius is 5.419 feet, we have a minimum surface area. So out of all other options of the radius, within a 500 cubic feet limit, that is where we would have the smallest surface area of our cylinder. So to guarantee, to prove, in fact, that this is where the minimum occurs, we want to go back, just like we did before with regular graphs that we wanted to minimize. We're going to make sure that this does, in fact, minimize the surface area. So we're going to just make a quick little sign chart, and knowing that we can't plug in 0 because this function is undefined at 0. So what I typically do is I just go very, very close to that 5.419, and I plug in 5, and then I plug in 6. But I do use the calculator for this. So let's go to your calculator and go ahead and get the cube root of that 500 divided by pi into your calculator, and then I'll show you what to do next. Okay, so this should be in your calculator now. So what I'm going to do is I want to test the surface area, or the derivative of the surface area, and I want to test the sign chart. So since it's kind of a complicated formula, I'm going to let the calculator help me out here. So what I want you to do next is put in the surface area derivative formula into your calculator. Okay, so you should have this. I used x as my variable, but you could use r if you wanted to for radius. So this is my surface area derivative formula. And I want to evaluate this. So instead of doing this kind of in my head, I can use the calculator. So I have this function, and to evaluate, I'm not sure what y'all have seen before on the calculator, but to evaluate, I'll just go through it really quickly. I want to evaluate this such that. So remember the symbol I taught you, such that is the vertical line. So to get a vertical line in the calculator, you press Control equals. When you press Control equals, you see the vertical line. So that vertical line, put that in there. So I want such that, and then x equals the value that I want. So I want to evaluate that at a point just to the left of 5.4 and just to the right of 5.4. So I'm going to put in 5. And if we want to minimize that surface area, then this should be a negative value. And it is. So on our sign chart, we can say, okay, at that 5, so or just to the left of the value, we have a negative. So then we need to go back and double check that just to the right of it is going to be a positive. So we're just going to go up highlight this again, delete the 5, let's put in 6 now, and see what we get, and we get a positive. So that is something that is valuable that you do need to double check, because I have seen problems where it's not minimizing. So you want to make sure and double check. Alright, so therefore this is in fact the minimum value of the radius, or the value of the radius, which minimizes the surface area. Now the problem stated that it wants the size tank that will take the least amount of time to build, so to give the radius and the height. We have the radius, so we need the height. So the height, we found a formula for that up at the beginning. The height is 500 over pi r squared. So again, use your calculator. Do not, when you plug in for r, do not put in 5.419. When you use your calculator, make sure that you use the exact value. So we have 500 divided by pi r squared. You could do the such that if you wanted, or you could plug it in. I tend to like the such that, so I'm going to put 500 pi r, or x squared, and then the such that. It really doesn't matter. This is personal preference. Okay, and then I'm going to say x equals, go up and highlight my exact value, and there's my height. And it actually turns out to be the same exact height. So when the radius is 5.419, the height is actually the exact same value. So let's add that into our problem. So what I'm going to do now is I'm going to write a final statement. So I'm going to pause and write out the statement. Okay, so here's my final concluding statement. Again, you want to regurgitate what the question asks. The size tank that will take the least amount of time to build would have a radius and a height of 5.419 feet. And something I want to mention here, when you write your final answer, when you're using a calculator, you want to make sure you have at least 3 decimal places. So from now on, hopefully you've watched this video, in order to get full credit, you need to have at least 3 correct decimal places. You can have more than 3, but if you have less than 3, then the question would be incorrect and you would lose a point. So keep that in mind. Now, we still haven't answered the entire question, because the question also asked how long will it take to build the tank. We know that a manual takes 15 minutes to put up each square foot, so we need to know how many square feet are in this tank. So what I would use is, instead of using the first surface area formula in terms of R and H, I'm going to use the surface area formula that was in terms of R only. So again, you can do the such that thing again if you want to. So let's go and use our calculators and find the surface area. Okay, so hopefully this is what you put in your calculator. Again, you can use the such that, or you can just plug in for x. So the surface area would be 276.791 feet cubed. But we want to know how long it takes, so we want to know that times 15 minutes. So if it takes a manual 15 minutes per square foot, it takes them 4,151. So depending on how the problem asked, you could say 4,151.86 minutes. However, that is only 2 decimal places. So just make sure that you have 3 decimal places. You can go up and highlight your answer, press enter, and now you can see 3 decimal places. So it's actually going to be 4151.858 minutes. So that is going to be my final thing. Okay, so the very final statement would be, it will take a manual 4,151.858 minutes to build the tank. So probably the question, it didn't specify, but that would actually translate to about 69 hours, which would be close to about 3 days for a manual to build this tank. So since the problem gave us minutes, I'm going to leave it in minutes. Otherwise, it should specify what kind of time it wants.